The prehistoric cosmic theory. The idea of detonation is generally accepted by the majority of researchers as the crucial clarification for the origins of the universe, enveloping the production of planets, stars, and all life, including us. Despite its fairly unconventional name, the term Big Bang effectively conveys the vastness of the initial event. In the universe, there was a thick assortment of particles pressed into a space the size of a pinhead. From this very moment on, a huge explosion took place, shortened to the Big Bang. In this way, it summarizes the interaction that took place. However, over billions of years, despite the enduring prestige of the idea about how things got to be. Progressions in scientific knowledge have increasingly questioned its predictions. Made before NASA launched the James Webb Space Telescope, the largest and most recent space observatory, scientists speculated that its theory would be strengthened by observations of an ancient cosmic explosion. Thankfully, after just 1 year in space, the telescope has astonished researchers because of its significant abilities that produce extraordinary appearances. The James Webb traveled into the universe's past. Telescope disclosures have revealed systems so old that they might actually reshape how we interpret the universe's origins. The reasons for this unexpected disclosure sparked intense interest among researchers and fans alike. One such significant disclosure occurred when Rohan Natu, a stargazer studying early photos taken with the James Webb Telescope, accidentally discovered a system that surprised everyone. This universe, named Glassy 1-3, appeared mysteriously enormous and traced all the way back to only shortly following the Big Bang, older than any world ever seen before. Natu's energy was tangible as he imparted the information to global partners, describing it as transcendent. The James Webb Telescope, positioned far from natural resistance and equipped with cutting-edge innovation, was designed to delve into the earliest age of the universe, known as the grandiose sunrise. During this time, the formation's covert mystery is an indication of the universe's most memorable stars and worlds. By studying the systems of this period, researchers hope to refine how they view significant cosmic cycles. Like the effect of dark matter, initial assumptions regarding energy for the James Webb Telescope's findings were modest, anticipating a few faraway universes, but the reality prevailed. All of the images projected by the telescope revealed systems of amazing development, challenging existing models and triggering a flurry of investigation. As researchers are still analyzing the data from the James Webb Telescope, these revelations may have repercussions, launching a new era of comprehension of the cosmos. Surprising disclosures from this noteworthy observatory offer a tempting observation. The universe is beyond driving humanity's journey to unravel the earliest systems of existence's secrets. Scholars and spectators ended up in a scramble to make sense of them, like this strange gathering of vast and brilliant early worlds, speculative perhaps, as a result of the examination of the initial telescope perceptions. Or, if they are true, may they ever be accommodated in some way with standard models of the cosmos. Possibly they were the main means that the cosmos is stranger and more complicated than our wildest predictions had assumed. The question isn't anything less than how we might interpret how the precise universe, as we know it, emerged from confusion in the early stages. Revelations from the James Webb Space Telescope could possibly revise the early portions of grandiose history. Sections focusing on ancient times in the distant systems and our own presence here as well, in the same effortless manner. Mark Makorian, a senior scientist at the Council for Investigation at the European Space Office involved with JWST, commented, "You build these machines not to affirm the worldview, but to break it. You just don't have the foggiest idea how it will break." Away JWST's perceptions of early universes have been billions of years in the making, but there is still more. They trace their roots back to the Space Telescope Science Foundation in 1985. The Hubble Space Telescope was As yet, 5 years from send-off. Regardless of the organization's efforts, Chief Riccardo Giacconi demanded that his group begin to consider the possibilities to pursue Hubble much further away. Despite initial fights about zeroing in on Hubble, Giacconi was tenacious, anticipating extensive growth. Deputy Overseer followed the process. Small group of people started coming up with ideas for the cutting-edge telescope, later renamed the James Webb Space Telescope. It was perceived that while Hubble would be groundbreaking, its capabilities would be restricted by its perceptions in observable light. JWST would see in the infrared range, allowing it to peer further into the universe. The requirement for JWST became significantly more evident in December 1995, when cosmologists directed the Hubble Deep Field Perception. Despite presumptions for locating a few faint cosmic systems, the subsequent picture revealed a huge number of worlds extending back more than 12 billion years in the universe. After more than 2 decades of improvement, and at a cost of approximately $1 billion, JWST finally launched on Christmas Day 2021. The telescope went through rigorous testing prior to reaching its fundamental space goal a month later. By July 2022, it was prepared to begin its hotly anticipated science first-year perceptions, known as Cycle 1. Some portion of JWST's initial mission was given to high-impact programs, including the early release Astronomical Evolution Science Survey and the GRIZZ Focal Point Amplified Overview from Space, both aimed at providing insight into the secrets of the early universe. As stargazers openly gave countless hours to scanning separate patches of the sky, looking for early cosmic universe systems. They initially anticipated modest discoveries similar to a more detailed variant of the Hubble Deep Field. However, they were in for a shock. Stephen Finkelstein from the College of Texas at Austin, driving the SEI project, explained that very far-off systems were supposed to arise solely after numerous information cycles. However, from various projects, cosmologists were fascinated by these universes that showed up very quickly. Previously, the record for the most far-off known system belonged to GNZ11, seen in 2015 with a redshift of 11, indicating expanding light as a result of the universe's expansion, with greater value demonstrating a wider separation. From the very beginning of perceptions through glass, 2 distinct groups, one of which was led by Rohan Natu, independently recognized Glassy 1-3, with a redshift of 13, extending the schedule back significantly further. In their scramble for quick results, specialists relied on improved redshift techniques based on brilliance estimations, as opposed to additional time-sensitive direct estimates. Despite their effortlessness, these evaluations quickly revealed brilliant and enormous worlds, some previously flaunting a heavenly mass equal to 1 billion suns, similar to our own. The energy didn't stop there. In the days to come, many universe competitors from GLASS and other surveys arose, some with redshift gauges as high as 20, showing that they were just a short time after the enormous detonation. These worlds showed disk-like designs, not expected in such early astronomical ages. And another group discovered proof of smooth waste systems at a redshift of 10 to 500 million years or less, following the enormous explosion's rapid rise. The rise of large universes poses a threat to expectations regarding the standard cosmological model, lambda-cold dark matter. To briefly comprehend this oddity, a return to the elements of the early universe is essential. In the preceding minutes following the enormous explosion, the universe was a hot, dense soup of early particles. Over the long haul, as the universe extended and cooled, helium and other small parts were framed, prompting the presence of the principal atoms around 400,000 years after. Approximately 100 million years after the enormous detonation, conditions became helpful for the development of the principal stars made essentially out of hydrogen and helium. These early stars, bigger and more splendid than current stars, amassed into protoworlds directed by the pull of dark matter's gravitational pull. However, Revelation argues against this model, as it uncovers splendid, sizable cosmic systems far sooner than anticipated. Reserve Western College noticed the shocking deficit of various ages, more modest protogalactic portions, indicating that some systems might be closer than assumed, hidden by dust, seeming dimmer and more far off. The disclosure of the early worlds raises significant concerns about the early stages of the universe, highlighting the need for continued investigation and amendment of our cosmological models. Follow-up perceptions of GLAS SC13 in August 2022 by the Atacama Large Millimeter Array in Chile created confusion for the underlying discoveries. Regardless of the utilization of brilliance-based estimations that ALMA was unaware of crucial indicators of the residue that is with GLA SSC13, as P. Tom B. from Goya College, who drove the perceptions, said this suggests that low redshift ALMA cannot be excluded as an intruder, attempted to identify the universe through regardless. This emphasizes the test of affirming perceptions made utilizing Rohan-Ne 2 is one of the JWST high capabilities. The in-question experts brought up the situation being out of balance, conveying the encouraging news that there's nothing was found. But he said the awful news is there's nothing identified with just JWST fit for circling back to its own perceptions. The most frightening clarification could be that the standard LCDM cosmological model calls for updating. Michael Bohan Cullen, a cosmologist, communicated the size of this potential outlook alteration. These outcomes are extremely astonishing and difficult to get in our standard model of cosmology. It would be a genuine revolution to comprehend. The one skepticism-laden proposition is alterations to Newtonian dynamics that challenge the existence of dark matter. WST perceptions could lend backing to MZ proposed by Mark McCarran. However, not all cosmologists are persuaded of MZ's validity. Yet another possibility is the possibility that early universe worlds have almost no residue, causing them to seem more beautiful and influencing the masses. Calculations that the situation might also figure out what ALMA's problem is. To honor GLASSC13, Charlotte Brickley and her partners made the proposal that JWST could be noticing the most beautiful young systems in the early universe that could only suggest star formation conditions during that age. David Spergel upholds this thought, recommending a massive star development could have been more proficient because of higher gas, potential temperatures, and tensions influenced by early attraction fields. The rapid distribution of logical papers from JWST initial perceptions mirrors a change to a regular companion survey through levels like A14 in virtual entertainment. While this speeds up, numerous discoveries have been made. There are worries about hurrying ends before extensive survey of companions. Despite issues with alignment and potential adjustments that have an impact on few outcomes, it's impossible that all high redshift cosmic systems saw by JWST will be nullified, all things taken into account. The sheer quantity of these worlds recommends that the early universe might be not the same as what was anticipated. Finlin, in the past, communicated trust in the validity of the disclosures, expressing that the chances of cosmologists being altogether base are small. Presently, stargazers are hurrying to direct subsequent perceptions with JWST. Nancy Levinson is currently evaluating approximately 12 suggestions from a variety of gatherings seeking additional JWST noticing time for the most part to examine the cosmic system's high redshift dependcomers. Given the energy in what these early disclosures mean, affirming them is vital. Troy Hu, who presented one of the recommendations, underscored the significance of affirming these discoveries. Different projects, like CosmosWeb, led by K2T, expect to expand the known populace of early systems by noticing a more extensive region of the sky for many hours. Fundamentally, they anticipated that they might identify great many systems. Besides, extra undertakings will look for proof of the main proto-universes. conceivably utilizing the unstable passings of supersized first stars and radiant cosmic explosion as indices of their actual existence. A few. According to evaluations, JWST could notice cosmic systems to the extent a redshift of 26. It's only 120 million years after the enormous detonation. Affirming even a small bunch of these high redshift newcomers would be a fantastic accomplishment. As indicated by NA2, demonstrating that cosmologists are not JWST has been diluted by their perceptions. Introduced an additional era in science. And regardless of the holes in the system, rapid correspondence of new information has inspired people to look at stars. Energy about the associated with an invigorated academic local area. Presently, the inquiry emerges as now is the right time to reconsider how we could interpret the very first sentence. Artisan Pond. The significant ramifications of looking into the data are completed by the unexplored world. For the time being, remember to lend a hand by preferring, buying, and then stirring things in the city for the future episodes. Also, make certain to share your reflections on the current content. Your support motivates us to keep communicating quality product and to always take a try at progress. Thanks for keeping an eye out, and we'll see you soon later. In conclusion, the James Webb Space Telescope JWST has begun a new era of exploration and discovery, challenging our comprehension of the cosmos' origins and evolution. Its unprecedented observations of newly formed galaxies after the Big Bang have sparked excitement and debate among scientists, expanding the scope of cosmology knowledge. The telescope's ability to look further into time and space than cosmic has never before been revealed phenomena that defy traditional explanations, causing existing evaluations to be reevaluated theories and the formulation of new ones, from distant galaxies to the enigma of dark matter and early star formation. JWST findings have profound implications for our comprehension of the past of the universe, eagerly anticipating the promises to continue to decipher the universes, complexes that provide glimpses into epochs that were previously out of our reach. It's not only advancing scientific discoveries inquiry, but also inspiring wonder and curiosity about the universe's vastness and our place within it. As JWST embarks on its mission to further explore, cosmologists are eagerly anticipating what new revelations lie ahead. With each observation, we move closer to unraveling existence's fundamental questions and gaining a greater understanding of the tapestry that essentially surrounds us. The James Webb Space Telescope stands as a testament to human curiosity and inventiveness, leading us to a more in-depth comprehension of our cosmic ancestry and our place in the universe's grand narrative.